Hi, welcome to the Unit 2B review. We're going to prepare for your test, which is coming. A couple of you may be wondering how exactly we're going to do this. I've given you a packet of review problems. What we're going to do today is go through some of those packets in this video. I'm going to go through them with you, show you step by step how you would do them, and hopefully you would be able to apply that knowledge to other examples in the packet. So what we'll do is you're going to take out that packet. As I'm going through, you'll locate the specific examples that I'm working on and follow along as we discuss them in the video. You'll use these to answer other questions in the packet that are similar to these. Before the test, you can always go back and watch the video again, kind of review over some of the things that we discussed in the video, and then any type of question that you're having, make sure you talk to me either today in class or tomorrow before the test. That said, we're going to go ahead and jump into it. Hopefully you're understanding what we're doing here. We're just going to be going through some examples to help you prepare for the test. All right, our first example deals with using the unit circle to find the exact value of the secant of 150 degrees. Well, in order to use the unit circle, we're going to have to look at the unit circle. You'll probably have one of those included in your packet. This one is the bottom one on the unit circle page. I've divided them into two sections. This one is going in increments of 30 degrees, as we can see, or pi over 6, if you remember the radian measure that we discussed. But for right now, I'll just go ahead and discuss it in degree measure. The first mark, we can see we've got the whole circle split up into 12 sections, and we're all aware that a circle contains 360 degrees, so the first mark would be 30 degrees. The second mark would be 60 degrees. Then we have 90 degrees, 120 degrees, 150 degrees, 180, 210, 240, 270, 300, and 330, and then of course we have 360, which is the beginning of the cycle again. The main thing we want to know, though, is the coordinates of these points that the endpoints of these angles are going through on the unit circle. And hopefully you remember, or you've become quite familiar with these by now. I will not go into how they are derived in this video. That's for another topic or another discussion. But you will hopefully remember that the first point has the coordinates square root of 3 over 2, 1/2. The next point would have the coordinates of those same values, just reversed, 1/2 square root of 3 over 2. And again, this comes all from the fact that our radius is 1 in the unit circle, and we're looking at a 30, 60, 90 triangle when we include the 30-degree angle and the 60-degree angle. Again, I won't go through much more than that as far as how this is derived here. The top part, again, we're going straight up. Our radius is 1, so this has the coordinates 0, 1. Then we go over here to 120, and it's the same values that we had over here, just kind of flip-flopped around. We're in the second quadrant, so our x-coordinate's negative, so we have negative 1/2 square root of 3 over 2. Same thing over here. We're going to flip this coordinate around. Our x-coordinate becomes negative again, so it's negative square root of 3 over 2, positive 1/2. To the left side, we've gone one space over, so that would be negative 1, 0. And then we just continue the same pattern with these values down into quadrant 3. So this would be negative square root of 3 over 2, negative 1/2. This point would be negative 1/2, negative square root of 3 over 2. Coming straight down here, this coordinate would be 0, negative 1. Over here we have the coordinates positive 1/2, negative square root of 3 over 2. And over here we have the coordinates positive square root of 3 over 2, negative 1/2. That's in quadrant 4. All right, and this last point, of course, is 1, 0. But at any rate, we're going to use these values to help us identify the trig function that we've been asked to find. Now, as you go through these, you'll learn, or hopefully you've already learned, that we can find the sine of any angle that's there, cosine of any angle, tangent of any angle, through using these values. The sine is always the y coordinate divided by the r. In this case, r is 1, so we won't even consider that. It's just y. Cosine is the x coordinate. The tangent is always the y coordinate divided by the x coordinate. Continuing along those same lines, the cosecant of every angle is the reciprocal of the sine, so that would be 1 over y. The secant of every angle would be the reciprocal of the cosine, which would be 1 over x, and the cotangent of every angle would be the reciprocal of the tangent, so that would be x over y. So using this information and going over here to look to find the secant of 150 degrees, we will simply identify that secant is the reciprocal of the x value. So we identify what the x value for 150 degrees is, and we can see that it's right at this point that our x coordinate is negative square root of 3 over 2. So what our secant is actually going to be is the reciprocal of negative square root of 3 over 2, which is also equal to negative 2 over square root of 3. That would be fine and dandy as long as we didn't have a radical on the bottom, but in this case we can see that that square root of 3 on the bottom of the fraction is not the way we want to wrap this problem up. So we'll rationalize that by multiplying square root of 3 to the top and the bottom, and that gives us a final answer of negative 2 square root of 3 over 3. And that is the secant of 150. I guess we could write it up here if we wanted. Negative 2 square root of 3 over 3. Hopefully you can write it a little bit better than Coach Hunt can. There you go. So that's the process we go through to use the unit circle. Again, you could probably find this using a calculator. However, it's not going to give you the exact value. You would get a decimal that's going to be irrational, and it's going to have to be rounded off at some point. So if we want to be accurate and we use the exact value, we're going to get that from the unit circle like we have here. Okay, continuing along, we're now going to jump down to number 9. Number 9 is asking us to use the trigonometric values, basically, or trigonometric functions to find each missing measure in these right triangles. So we're looking to find the value x out here, which is the hypotenuse, and we have this value 4 in relation to the angle 65. We're going to need to know and understand some things about our trigonometric functions, and we've discussed these in class, so hopefully you're familiar enough to remember or recall that sine of an angle is equal to the opposite leg over the hypotenuse, and I'm just abbreviating here. Cosine is equal to the adjacent leg over the hypotenuse, and of course tangent would be the opposite leg over the adjacent leg. So knowing this tells us or helps us identify which function we should be using in this problem. Now in this problem I have 4, which is the angle, or excuse me, which is the leg that is adjacent to the hypotenuse, or excuse me, adjacent to the angle that we've been given. And I have the hypotenuse that I'm looking for. So I'm going to look for the function that deals with the adjacent leg and the hypotenuse, and here we can see that would be cosine. So we're going to use that information to solve this problem. We're going to say cosine of 65 degrees is equal to the adjacent leg, which is 4, over x. Now at this point, we've got our equation set up, and we just have to follow our algebraic rules and use our calculator to find the cosine of 65. Multiplying x from off the bottom, we'll get x times the cosine of 65 degrees. That's equal to 4. And of course, x would be equal to 4 divided by cosine of 65 degrees. Now notice that we are talking about 65 degrees here. So you need to make sure that your calculator is in the proper mode. And of course, since we're talking about angles being measured in degrees, we will make sure our calculator is in degree mode. Make sure of that anytime you reset your calculator. A lot of time the default settings end up being radian measure, which we do not want to be using here. So as we type in 4 divided by cosine of 65, you can find that with your calculator. You'll get that x is 9.4648. We're going to round that off to 9.5. We'll just say we're going to round everything to the nearest tenth in this activity. So our value for x, so that hypotenuse would be 9.5. Okay, continuing along down to number 12, you can see in number 12 we have a similar situation. However, we've been given two sides, this hypotenuse and this leg of the triangle. We do not know the measure of the angle, and it's an important thing for you to remember that you go about this a little differently when you're finding the measure of an angle versus the measure of a side. So here we've got, in relation to the angle that we've got the opposite leg, that's the leg all the way across from the angle, and we've got the hypotenuse, the longest side of the triangle, which is across from the right angle. So opposite leg and hypotenuse will not be cosine, it will be sine. So we're going to use the sine value here of theta to help us find what theta is. We're going to say that the sine of theta is equal to the opposite leg, which is 4, over the hypotenuse, which is 7. Now in doing that, we need to understand that we are trying to find theta, so we've got to get sine away from this. So we're basically going to ask our calculator what angle would have a sine of 4/7. So we'll find the arc sine of 4/7. We use the arc sine, the arc cosine, and arc tangent whenever we are trying to identify the measure of an angle. These are all used to find angle measures. So remember, anytime you're in a triangle problem and you're looking to find the measure of that angle, we're going to have to resort to using an arc sine, an arc cosine, or an arc tangent. Well, hopefully at this point you've recognized that you can just type this in your calculator, arc sine of 4/7, and by doing that we can find the value of theta. Your calculator will give you 34.8499, something around there. We're going to round this off to 34.8 using our rounding rules of doing it to the nearest tenth. So theta in this case is a 34.8 degree angle. Okay, moving along, we're going to jump ahead to number 14. Number 14 is a word problem. Hopefully, I know some of you do not like to do word problems. Hopefully you'll take some moments and read through these and learn to decipher what information is being given. In this one, a kite is attached to 120 feet of string, is tied to the ground, and the string makes an angle of 58 degrees with the ground. The question is, how high is this kite? Okay, so I've taken a moment here and put up a drawing of the situation. We've got a kite that's tied to the ground, and the kite is on 120 feet of string. Well, hopefully you've been around flying kites around enough to know that the string would be the part that's going right here. So this is 120 feet right here. is tied to the ground and the string is making a 58-degree angle with the ground. So from the string to the ground is 58 degrees. Now what we want to know is how high is the kite? Well, we would measure that distance along a directly vertical path or an altitude to find that length. So that's what we're trying to find. Now we would measure that length again on a path that is perpendicular to the ground. So what we get here is a 90-degree angle, making this a right triangle. So what we're looking for is the leg that is opposite of our 58-degree angle, and we have the hypotenuse, which is the string. So we're going to use the function that deals with opposite leg and hypotenuse. And if you remember, we just discussed this in a previous problem. Opposite leg and hypotenuse would be sine. So we know that the sine of 58 degrees is equal to x, whatever it is, over 120. So we're just going to find x by multiplying 120 over. So we have 120 times the sine of 58 degrees will give us the value x. Now as you punch that into your calculator, you'll be getting something like 101.76577. We'll stick to our trend of rounding everything to the nearest tenth, so we'll say that's about 101.8 feet. That is how high this kite is up in the air. Okay, now we're going to continue and look at number 20. As we go to number 20, we'll see that we've been asked to solve a right triangle. A right triangle, of course, has a right angle in it. When we're asked to solve a triangle means to find all of the angles and all of the sides. Well, we've been given in number 20, and obviously in different problems you'll be given different things. In number 20, we've been given the lengths of two sides. The sides, we always know those are measures of sides because they're lowercase letters. Side B is 15, and we know that side C is 20. Well, side C is our hypotenuse, so that's handy. We have the hypotenuse of 20. We have the leg over there, leg B, is 15. So what we need to do is find length A. We're going to have to find this angle here, angle A, and we're going to have to find angle B as well. So we're going to take a few moments and do that. The first thing we'll probably want to find is side A. We'll do so in a right triangle. When we have two sides, we can use what we call the Pythagorean Theorem. And that basically tells us that a squared plus b squared would be equal to c squared. And in this triangle, the letters fit just perfectly. A squared plus b squared equals c squared. So using that information, we know that a squared plus 15 squared would equal 20 squared. And real quickly, that's a squared plus 15 squared. 15 squared is 125. No, it's not. Excuse me. 225. And that's equal to 400. So we would subtract the 225 over. So a squared is equal to 175. And a then would be the square root of that, which is about, following a rule rounding to 10, it's going to be about 13.2. If you punch that in the calculator, you'll get something that rounds off to 13.2. So we're going to use that for right now as our measure for A. Continuing along, we're going to have to find angle A and angle B. So we'll find one of those. Let's say, for instance, we choose to find angle B first. Doing so, I'm going to use the values that I had to begin with. I won't trust this 13.2 right yet, because if I made a mistake there, it's going to throw everything else off. So we're going to use the given values as much as we can. So we have the opposite leg and we have the hypotenuse, so that would be sine. And we know that the sine of angle B is equal to 15/20. And again, like we mentioned before, if we are finding an angle, we're going to want to do the arc sine of the function. So our measure of angle B would be the arc sine of 15/20, or 0.75. So we punch that in the calculator, and we will find that angle B is about 48.6 degrees. So we know that that measure is 48.6. Now, another rule that we know about triangles is that the sum of all three angles is 180 degrees. Well, we have two of them. We know that this is 90 degrees. We know that this is 48.6 degrees. So we can easily subtract those out and find our last angle to be 41.4 degrees. So the measure of angle A is 41.4, angle B is 48.6, side A is 13.2. I've identified all parts of this triangle, so we have solved the right triangle. Okay, now we're going to jump over to 22. In number 22, we do not have a right triangle. We don't have a triangle that has any right angles in it. So we just have a general shaped triangle. We don't know what it is. In fact, this triangle here that I've got pictured is not what this triangle looks like in any way, shape, or form. It's just a triangle that I've put there for us to use to go by and identify some patterns. So as we look at this, we're going to mark off what we do know on this triangle. The things that we do know are that side A is 10. Side A is the side across from angle A. Angle A is 100 degrees. That's a misprint. That should be 100 degrees. And side B is 4. So by doing this, we've got a few things to look at, and we're going to have to find angle B, angle C. We're going to have to find side C in order to solve this triangle. So looking at this, we can see that we have one angle and the side across from it. Now, what that tells us is that we should use the law of sines. Okay, and anytime we have an angle and the side across from that angle or opposite of that angle, we are going to refer to this as our method, the law of sines. See if I can write it a little nicer. The law of sines to solve this triangle. If we don't have that scenario, we'll have to resort to some other measures we'll talk about in a minute. But if we have the law of sines, what that tells us is that the sine of 100 over 10 is a ratio that will be the same for every angle and its opposite side in this triangle. So the sine of 100 over 10 would be equal to the sine of angle B over 4. Now, to solve this is just a simple proportion, and to solve this, we're going to have to cross multiply. So to solve this, we'll multiply 4 times the sine of 100 and 10 times the sine of B. So we'll get this equation: 4 sine of 100, that's degrees, equals 10 times the sine of B. Now, to solve this, of course, since we're trying to solve for B, we'll have to divide back by 10. So we'll have 4 sine of 100 over 10 is equal to the sine of B. And then, of course, we're going to find the angle B. So we'll have to use the arc sine. So we'll say the arc sine of 4 times the sine of 100 over 10 is what B is equal to. Now, we've gone through this in class of several different techniques about typing this in the calculator. I will give you a word of caution. If you're trying to type it in all at once, make sure that you place your parentheses properly in the calculator. Otherwise, you can run into some real sticky situations. As we find this, we find that angle B, I believe the calculator will tell you 23.1988, something or other. We're going to round this off. We'll stick to our rule of round to the nearest tenth, so we'll call this 23.2 degrees. And I guess I'll make the, we've rounded that off, I'll make the rounded off symbol. All right, so we've got B is approximately 23.2 degrees. We can mark that off on our drawing. All right, the remaining parts to find would be angle C and side C. Well, we can find angle C by just subtracting 123.2 from the sum of all the angles, which would be 180. When we subtract that out, we'll find that angle C is 56.8 degrees. Again, remember that all three angles have to add up to be 180 degrees. So if I know two of them, I just subtract to find the third. All right, now to find side C, we're going to go back and use sine of 100 over 10 and set that equal to, this time, we want to use 56.8 with C. So we'll use sine of 56.8 degrees over whatever C is. And again, we're going to cross multiply to solve this. So we have the equation C times the sine of 100 is equal to 10 times the sine of 56.8. To find C, we have to divide by a sine of 100. So we can complete this real quickly by saying C is equal to 10 times sine of 56.8 divided by the sine of 100. And you can easily punch that in a calculator and find the length of side C. It comes out as 8.4967. We'll round that off to about 8.5 using our rule of rounding to the nearest tenth. So this side over here is our last piece to find, and that is 8.5 for side C. So we've found all the angles, and we've found all the missing sides. So this triangle has been solved. All right, our last problem for the video is number 24. Now, as we look at number 24, we're given a little bit of different scenario here. We have three sides that we've been given. Side A is 11. Side B we know is 13, and side C we know is 20. Now, in this case, we do not have an angle with the opposite side. So remember, I told you if we had an angle with the opposite side, that was the situation we were looking for so that we could use the law of sines. In this case, we do not have that. So what we're going to have to use is the law of cosines. And it's very important that we know which of these methods we're going to have to use. Obviously, we want to use the law of sines first, as we've talked about in class. It's a much easier method. However, sometimes we have to resort to using the law of cosines. So that's what we'll be using in this problem. We always start, when we're finding angles, we want to find the smaller angles first. And that's our guideline that we want to follow as we do this. We've talked about the fact that as we're using calculators to compute these trig functions, the calculators don't acknowledge obtuse angles. So if we're trying to find an obtuse angle here, particularly if we're going to use the sine of something, which we'll be getting to later, if you're going to use that, you definitely want to make sure you're finding the acute angles first and subtract it from 180 to find the obtuse angle, because it just won't work otherwise. All right, so we're going to use our smallest side first, or our smallest angle, which means we're going to use this smallest side across from that. It tells us that A is the smallest angle. So we'll use the formula that A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. Now that is the law of cosines. That's what it tells us. So in this triangle, that would be 11 squared is equal to 13 squared plus 20 squared minus 2 times 13 times 20 times the cosine of angle A, whatever angle A is. Now 11 squared is 121, 13 squared is 169, 20 squared is 400, 2 times 13 times 20 is 520, and we have cosine A here. Now, as I've warned you in class, make sure you follow the order of operations as we go to solve this equation. We have a tendency to want to combine all three of these numbers, and we are not allowed to do that. We can only combine the first two. So that would be 121 is equal to 569 minus 520 times the cosine of A. Now remember, 520 is being multiplied times the cosine of A there. I cannot subtract it from 569, no matter how much I want to, no matter how much it may look like that's what I should be doing. I should not do that here. I will subtract 569 from both sides at this point, and I will get that negative 448 is equal to negative 520 times the cosine of A. Let's see if we can get a little more room here to work this out. So as we do this, cosine of A will be equal to negative 448 divided by negative 520. And since we're trying to find an angle, we will do the arc cosine, or we will utilize the arc cosine of that angle, or of that ratio, to find angle A. So we punch in arc cosine of negative 448 over negative 520. I didn't write the negatives there, but you know that that's going to be positive as we do negative over negative. That gives us that angle A is approximately, it gives you 30.51 something. We'll say 30.5 based on our rules. 30.5 degrees for angle A. So we can mark that, and we know it. At this point, you're going to have to use something else to find another angle. We want to find the next smallest angle. Again, by our rule, that would be 13 tells us that angle B is the next smallest angle. So we're going to find that next. We'll say that the sine, we're going to use the law of sines now since we have this opposite side and angle. So we'll say sine of 30.5 over 11 is equal to sine of B over 13. We multiply over the 13, so we have 13 times sine of 30.5 divided by 11 is equal to the sine of B. And of course we'll find B by doing the arc sine of all that. 13 is our arc sine of 13, sine of 30.5, all divided by 11. And that will give us angle B. As you punch that in your calculator, you will find B is 36.856868, repeating. So that's going to end up telling us that B, as we round it off, would be about 36.9 degrees. And of course we can finish that out by finding the last angle by subtracting from 180. 30.5 and 36.9, as we subtract them from 180, we find that angle C is 112.6 degrees. And that is how we use the law of cosines to find, to solve a triangle. Of course, as I said, you always want to make sure that we use our smaller angles, or use what we have to do to find our smaller angles first, or else we're going to run into some complications. Okay, that sums up our video on the review. Obviously, there are some other questions in the packet. Please take some time and complete those. If you're having any questions, please speak up in class, ask for help. Again, you might want to review over this video or parts of this video tomorrow before the test, and get lots of practice in, get some extra studying. Good luck, and I'll see you in class.